gmail.com. And if you like this video, please don't forget to smash the like button and share this video with as many people as you can. And if you have not subscribed to my channel yet, please kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about a more advanced layout in GTK. So we will get a look on a much more advanced layout in GTK than before in our labels and layout video. So we'll get a look at a much more advanced layout. And yeah, so instead of boxes now we'll start using tables also. So without any delay, let's get started. Damn! So we mentioned in the previous video that boxes can be either horizontal or vertical. So for example, over here we create a vertical box, right? So this is all our code from the previous video, and let's just brush this up over here. So we have a count 0, we have our end program method that will get a widget and a general purpose pointer, and it will basically terminate out of a program. Then we have a count button method that will receive a widget and a general purpose pointer also. And this is just creating a buffer string of 30 chars, and then it is incrementing the value of count. It is printing into the string buffer that button pressed %d times and count times. So button pressed 1 times, 2 times, 3 times, 4 times, and so on. Buffer will keep on updating whenever this will be called count button. And then we are just setting our label text. So GTK label set text, GTK label pointers, and pointer will get a label widget that which we are typecasting to a GTK label, right? So just to remain safe, we are typecasting it to a GTK label or pointer. That will be a GTK label, and we are seeing it to set the value buffer as our label text. So we are setting buffer as the label's text. Then in a main method, we are just initializing GTK and passing it argc and argv, and we are creating a window widget that will be our top level window. We are creating a button widget that will be a button which will have the label close window. We are connecting two signals to it, one to the button clicked, and whenever we receive this signal, whatever method we pass to g callback, that will be called. So end program will be called, in which the first argument will be the widget that invoked the function. So button invoked the function, so the first argument is button, and then second argument is whatever we pass over here. So we are passing null, so g pointer will be null, right? So whenever the button will be clicked, basically it will end our program. The same thing we are doing, but when our X button will be clicked on our window, right? So whenever the X button will be clicked on our window, the method that is passed to our G callback method will be called, and to that method it will pass first of all the widget that invoke the method. So window widget invoke the end program method, so that's why the first widget that will be passed to end program will be window, and then the second argument will be the one over here that is null, so the general purpose pointer will be null. And then we are creating a widget, label widget, and basically this is a new label, and the text written in it by default is my label. Then we have a button 2, so this is a GTK button, a new with label, and it is a count button, and we are attaching a signal to it. So we are attaching a signal to button 2, a click signal, and whenever it will be clicked, it will call the method that is passed to g callback. Count button will be called, so count button will receive first of all button 2, so that is the widget that invoked the function. So it will receive the first argument will be the widget that invoked the function, so button 2 it will receive, right? So it will receive button 2 over here as the first argument, and the second argument will be the thing that we passed over here. So we are passing label, so the general purpose pointer will now have the label as we expected it to have, so that we can change the value of our label in this method. So in this we are just because we are passing a label, that's why we are able to change the text of a label, and we are typecasting our label to a label so that the compiler does not throw warnings and stuff, and we stay sure that a label type is being passed to GTK label set text, and it will set the text to whatever buffer's value is. Then we are creating a GTK widget, that is a box, and we are creating a vertical box, right? And then we are passing it false and 5. The false is that if it is homogeneous or not, right? So the false is basically saying that if it is homogeneous or not, meaning that if all the widgets in this box will occupy the same amount of space, or the space that is required by every widget. And then 5 is basically the number of pixels, so this is the distance between all the widgets, right? So this 5 pixels is the distance between all the widgets we add in our box. And then we are calling GTK box pack start, passing it box, and then the widget that we want to add into our box, and then we are giving true, and 0. And right now we'll see what these other three arguments are doing, because in the last video we didn't get to know what these three arguments are doing, but in this video we'll get to know what these three arguments are doing. Then we are just calling this pack start again, and passing it GTK box, right? And our box we are passing it because in this we want to add another component widget, sorry, that is a label widget. And then we have given these three arguments that we'll learn about. And then finally we have GTK box pack start. We are calling once again, passing it the box in which we want to add the button widget now. And these are the three arguments that we'll see right now. And then now in the box we have all our three widgets. So now what we'll do, we'll in our container, that is our window, so we are typecasting window to a container, and in that window we are adding our whole box that contains other widgets. And then we are just showing all the widgets and passing it window. So in window we are just showing all the widgets, and then we are handing the control to GTK. Now if we save this and compile this, sorry, and then run this. So now you will see, you will have a count button, you press it, and then it will keep track of how many times the button was pressed, and then you resize it. So according to that, the label, button, and the label and the buttons will resize, so according to that. But using now because of these three arguments, we can say if it has to resize or not, and we can handle how it looks. And so basically we can handle everything on our screen, that how the button will look when it resizes, or we can we have multiple styling options with these three arguments, right? Similarly we are doing the same thing, the exact same thing, but right now instead of a vertical box, we are giving over here to our box an horizontal box, right? So this is the only difference now, and let's see what happens now. Now everything, instead of coming vertically, is coming horizontally. So instead of coming vertically everything, it is coming horizontally. So this is the main difference between GTK V box and GTK H box, right? Now let's read some text. So what about those other arguments to GTK box pack start that we glossed over earlier? So what about these three arguments that are being passed and we don't know about? These are designed to allow you to move things around within boxes to give you more control over exactly where things end up within the window. So these will basically help you define where your widget will end up on the window, right? And this will give you more control in defining that. So in the windows we have seen so far, this doesn't seem particularly useful, as the button and label both take up as much space as they need, but no more, because we have given false over here, right? So we have given, as we have seen, we have given false over here. So this is saying that it should take as much space as basically. So we are saying, using giving false, that the widget should take as much space as it is needed, right? And if we give true, it will say that all the widgets in our window will take the equal amount of space, right? So over here, in the windows we have seen so far, this doesn't seem particularly useful, as the button and the label both take up as much space as they need, but no more. But GTK windows can usually be resized. The user can grab a corner of a window and stretch it to an arbitrary size in each dimension. GTK tries to resize windows and widgets intelligently so that things grow and shrink in proportion to each other. So, like if you grow the window, then it will keep all your widgets in proportion and grow them in proportion, right? And then if you shrink the window, it will shrink all your widgets in proportion, right? So these additional arguments let you control what happens to the widgets when the window size changes, right? So now we know that these additional arguments will help us help us tell that what will happen when the window size really changes, right? So the third argument to GTK box pack start is called expand. So this third argument over here, this is called expand. If set to true, then when a window is enlarged. So if this expand is set to true, when the window will be enlarged, the amount of space allocated for this widget is enlarged in proportion. So if we set this to true, then when a window will be enlarged, so if we grow the window, the amount of space allocated for the widget is enlarged in proportion. If set to false, the amount of space allocated for this widget is never more than the minimum it requires. So if we set to false, it will take the space allocated for this widget will be never more than the minimum it requires. So it will always keep the minimum space for that widget that it requires. So the fourth argument is called fill. So this and this is called fill, right? So this has no effect if expand is set to false. So if expand is set to false, this fourth argument will have no effect. If you set it to true, false, anything, it will have no effect if the expand is set to false. But if expand is set to true, it controls whether or not it is the space allocated to the widget or the widget itself which grows. So it controls basically whether or not it is the space allocated to the widget or the widget itself which grows. So for example, when you resize the window and make it bigger, then this argument, fill argument, will tell if that widget should take the whole space that is allocated for it, the grown space that is allocated for it, or the widget should remain the same size and the space around it should should fill over there as much. So basically, the grown space that will be allocated for our widget, Phil will say that the widget should be showed on the whole grown space, or it should be the same size, but the space around it should be filled over there. So we'll understand it with some examples. So it basically controls whether or not it is the space allocated to the widget or the widget itself which grows. If expand is true, and the fill is false, the widget itself stays the same size, but the space around it grows. If both expand and fill are true, the widget itself grows to fill the increased space. That is somewhat hard to follow when written down, but a few examples will help to get it straight. Change the GTK H box back to GTK V box, and then set both expand and fill for all three GTK box package start call to false. If you then resize the window, the label and two buttons will all stay the same height at top of the window. So they will all stay the same height at the top of the window. So let's see. So now instead of giving true, 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 you have given false, 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 false. So expand is false, and when expand is false, fill has no effect. So expand is false, so the widgets won't expand. So, sorry, I always open PowerPoint. Force quit PowerPoint. Okay, so now you can see I'm taking the window over here, and now when I grow this, these buttons shouldn't grow. So you can see over here, their height is not growing, but still their width is growing. We are gonna solve this also in the future, right now in the video, but you can see now its height is not growing, that is remaining constant, but the width is still growing, and we need to solve that. We'll solve that, but right now we just need to notice that the height is not growing, and that's a good sign. Now try the same thing, but change the expand parameter in the GTK box pack start for the button. So for only the button to true. So now for only the button, we have set it to true, the expand argument. So let's see what happens. So this basically only the button will expand. Let's see what happens. So when I grow this, then you can see only the button over here is expanding, but the button itself is not expanding because we have set fill to false, so the button won't fill the whole space, the expanded space. The space around the button will fill the expanded space because we have given fill to false, and this looks quite cool. So the button now moves down the window to fit in the middle of the increased space. The extra space has been allocated to the button, but the button itself is the same size. Finally, try changing the both expand and fill to true for button to see a result like this image overlay. Okay, so there's no image. I forget to. Uh, I forgot to add that. So now over here we have said both expand and fill to true. So what do you expect? It's quite clear. We expect to see that the whole button is covering our screen. Not the screen, the space, expanded space that is allocated to it. So now let's go to our window. So now as I expand this close window button should expand vertically and horizontally too. So closed window is expanding, and it is covering the whole expanded space that is allocated. So now if I keep holding this down, so you can see the whole button is being pressed down, and then when I release it, the button click was successful and it basically closed our window. So this is just fine, but always we won't want everything like in a stack or horizontally, right, in a row. So we always won't want something in a column or in a row. We want like some element like this, some element like this, and then like two elements like this, two elements like this, and like we don't want a specific type of order in our application. We really want to make so basically we want to make the best out of our layout. So basically like we can have two widgets like this over here, two widgets like this, and we can so basically using something else would make it basically much more neater and cleaner and more a wanting result. So using something else will give us something more wanted, right? So enlarging the window now causes the whole button to fill the extra space. We can see that these parameters only affect the vertical size of the widgets. This is because they are used in a GTK VBox. It is not affecting the horizontal size of our widgets, but it is only affecting the vertical size of our widgets because it is used in a GTK VBox, which contains a set of GT. Okay, so because they are used inside a GTK VBox. So if we want to control the horizontal size of the widgets as well, we need to use a GTK VBox which contains a set of GTK edge boxes. So we need to use a GTK VBox in which there will be other GTK edge boxes, right? We will need a GTK VBox which will contain a set of GTK edge boxes if we want to control the horizontal layout also, which are then used to contain the widgets themselves. The final argument in the call to GTK box pack start is called padding. This is the amount of free space in pixels which is inserted at either end of this widget. This is in addition to to the spacing which was requested between all widgets in the GTK box new call. So, by careful tweaking of expand, fill, and padding parameters, you can create a window which displays all its widgets tidily and resizes exactly as you expect. Now let's move on to a complex layout, that is our tables layout, right? So a tables layout is a more complex layout for us. So basically this tables layout is a more complex layout where we can we'll get the exactly wanted result, the result that we exactly want. So you might be wondering how to put say 4 items in a window with 2 on each of 2 lines. So like 2 like this, 2 like this. Well, it is perfectly acceptable to put an GTK H box as one of the items inside a GTK V box or vice versa. So you can give like GTK, you can give a GTK V box and then you can give a GTK two GTK H boxes inside your GTK V box, and or you can give a GTK H box in which you can give 2 GTK V boxes inside your GTK H box, right? So this could be acceptable. So it's even acceptable to put an GTK H box as an item inside an GTK H box, but it's generally a bit pointless because like you have a horizontal box and then inside that you add a horizontal box. You don't need that because using the outer horizontal box only, you can style all the widgets that you need as a horizontal box. You don't need in another horizontal box to style it as a horizontal box. So basically, it is pointless, right? A horizontal box inside a horizontal box. If you try to picturize it, like over here you have a horizontal box, inside that you add a horizontal box, and inside that you add widgets, and those widgets could have been styled uh, yeah, in the inner those widgets are being styled in the inner horizontal box, and they would have been styled the same in your outer horizontal box also. So like it is a bit pointless whenever you add a horizontal box inside a horizontal box. Using a combination of nested GTK H boxes and GTK V boxes, you can lay out all the widgets in a window the way you want them. While nesting GTK Edge boxes and GTK V boxes works perfectly well for laying out widgets in 2 dimensions and actually gives you the best control over how they appear, there is a simpler alternative, the GTK table widget. So there's a very simple alternative, guys, that is the GTK table widget. A GTK table is a 2 dimensional box which is defined as having a certain number of rows and columns when it is created. So it can when we define it, we specify a certain how many rows and columns should be there in our GTK table. Widgets can then be located at various row and column coordinates. So basically widgets can then be located at various row and column coordinates, right? So this is actually not as flexible as using nested GTK edge boxes and GTK V boxes, because every widget has to be aligned in both a row and a column. This means that any row is always at least as high as the tallest widget anywhere in it. So basically any row is always at the this means that any row is always at least as high as the tallest widget anywhere in it, right? So if you have a very tall widget in it, that row will be as high as the tallest widget anywhere in it, and any column is always at least as wide as the widest widget anywhere in it. This can lead to a lot of wasted space, but quite often a simple arrangement like this is all that is needed. So a GTK table works fine in simple programs, but in complex programs, you may need to use GTK V boxes inside GTK H boxes or vice versa. Here are the changes to our example if we use a GTK table to position the label and button. So let's just uncomment this code. And let's see this over here, guys. So till now we have the same program, till the main method we are initializing, and then we are creating a window widget and our button widget. We are connecting the signals to it. We are creating a label widget and a button too. We are connecting another signal to it, and then what we are creating a GTK widget that is table. Now our box code has been removed. We are creating a table using GTK table new, and it accepts three arguments. Over here we are giving it 2 and true. 2 over here is representing how many so basically the arguments to the GTK table new function are the number of rows and the number of columns respectively. So this is saying how many rows will be there. So there will be 2 rows, and how many columns? 2 columns. And whether or not the table is homogeneous, which in the case of table is whether or not every cell in the table is identically sized. So we are saying that every so basically we are saying right now in this case of table is so which in this case of a table is whether or not every cell in the table is identically sized. So we are saying every cell in the table is identically sized by giving true. If we give false, we would have said that every cell in the table is not identically sized. True will give us a neater layout, that's why we are giving true. Okay, so let's continue now. So over here, what we're doing, we're doing GTK table attach defaults. So now we are attaching a widget to our table. So we are adding a widget to our table, and we are specifying to which table, in which table we need to add the widget. So in the table we need to add a widget, and we're just basically typecasting it to a table so that we remain sure that we are adding the widget to a table, right? Then we are passing it label. So which widget we want to add? The label widget we want to add. Then we are over here defining on the x-axis where should we add it. So from 0 till 1, right? So from x-axis we want to add it from 0 till 1, right? So like this. So like there is 0, 1, 2. So from 0 till 1 we want to add it, but now it could be in either of the rows, on the 0th row or on the 1st row. So over here also we are this is over here defining the y-axis, 0 till 1. So over here let's try to understand using comments. So how can I get okay, so 3 and then 3 and then like this, and then 1 2 3, 1 2 3, like this, 1 2 3, this, and then finally and then 0 1 and 2. So now in the x-axis, we want to add from 0 till 1. So from 0 till 1 we want to add our widget, our label widgets. So now it could be over here or it could be over here. So then we are specifying on the y-axis, we want it from 0 till 1. So from 0 till 1. So now over here, this is specified that a label should be on this cell over here. Then what we are doing, we are attaching to our table so to our TBL table, our button 2. So our button 2, that is our counter button, we are attaching that to our table. And this on the x-axis we are specifying 1 comma 2. So 1 comma 2, it is 1. So this was from 0 till 1. So this is from 1 till 2. So now it could be this or this, right? So it could be this or it could be this. So now over here we are specifying on the y-axis from 0 till 1. So from 0 till 1. So from 1 and 2 and 0 and 1. So on this cell over here will be our button 2, that is our counter button. And then finally we are attaching to our table a button, right? So a button, that close window button, from 0 till 2. So from 0 till 1 and till 2. So from 0 till 2 till the end, covering the whole row. And now it could be this whole row or this whole row. So let's specify the y-axis from 1 till 2. So this was 0 till 1. So till 1 till 2. So it will be this whole thing, right? So this whole thing will contain a button. So over here we'll have a label, over here we'll have a button 2, and finally over in this whole thing we'll have our button, that is our close window button. So in this case, now the widget span the first and the second columns because it is attached to 0 at the left and to the 2 at the right. So from 0 at the left, and this is 1 and this is 2. So it till the 2 at the right. Right? So for completeness, note that GTK table attach defaults is a shortened version of the function GTK table attach, which has several other options. These other options include the ability to specify expand, fill, and padding options for each widget, as in the GTK box pack functions described in the previous video, sorry, not chapter. But these function calls then get rather long-winded to type out. Using GTK table attach defaults sets padding to 0 and set expand and fill both to true for each widget. Feel free to play with the full version if you want. Note the close window button spans both columns of the table as described above. Right? So now over here we should have our label, over here we should have our count button, and finally below them should be our close window button that will span both the columns. So compiling, running, and then over here you can see here we have a label, here we have a count button, and then here we have a close window. So we count, and you can see this is some very cool stuff, and then I can press close window. And This was it, guys, for this video. I hope you liked the video, guys. If you did, please don't forget to smash the like button and share this video with as many people as you can. Thank you, guys. Bye. Stay safe, stay healthy, and keep watching my videos. Then